don't need a ton of like work for. Now this is the one where we don't want to kill puppies, so we'll talk about that when that comes up.
Yeah, we don't want to kill puppies.
So example 15 here, we're just distributing this in. So this is 5x to the second minus 10x. So we're just distributing. Then if we're able to, we combine like terms. So you distribute first, then combine like terms. And again, we're going to end up doing these with some trig functions. So we want to know how to do this. And again, obviously these are things, like I said, it was basic. Like, so hopefully this is just to kind of just remind you of things you already knew how to do. I'm not anticipating this is anything new for anyone. So this next one we would need to do FOIL. And then see if there's any like terms. But I do not believe there's going to be, right? And I wrote it in standard form. If you have it like out of order, it's fine. Now number 17 is the one where you could end up killing puppies.
Uh-oh, SpaghettiOs.
Do you know what we're not supposed to do?
Just, you're not supposed to
I said we gotta square it.
You gotta foil it.
Distribute the exponent.
Yeah, just distributing the exponent kills puppies. Let me see.
Imagine. These nuts, you can't just distribute, you gotta foil it.
You can't distribute these
You
nuts?
just can't distribute them with these nuts. You
You
really
can't
gotta
distribute
foil
these
I don't know if I
nuts.
had that one on here.
Luke, just stop talking about these nuts.
The puppy bit.
Very
The puppy
necessary.
pictures.
What's his name?
What are these roads?
These?
Nuts.
Got him.
Luke's really finessing people over here.
This is true.
This is true.
I think you should be math
Hey,
means.
just quiet.
I know. Oh, there's even a sign one left.
The dead puppy theorem. Wow.
Dead puppy theorem.
And it's corollary. Wow.
You're good at reading.
Corollary. All right. So no, just distributing the power in. Distributing the power in is a big no-no because that cute little puppy waving to you is not any longer there. All right. So we have to. If you guys heard, Luke said we need to FOIL this. So bless you. So again, we have to write it twice because it's being squared. And then I'll have some like terms to put together. So you get a different answer if you just distribute that power in. So we need to make sure we FOIL there. And then finally, this last distributive property one is actually called a conjugate. Those guys who recently had another math class, you probably remember this more frequently because we use it so much. When we have the exact same terms but just one opposite side, it will always cause those middle terms to cancel out, which can be helpful with like imaginary numbers and be helpful with radicals. I mean, we use it for lots of different reasons. Because of those opposite signs, we're always going to lose those middle two terms. And that'll happen every time if you have what we have using a conjugate. You don't have to know that name, it's just I'll use it from time to time. So that's something we'll use quite a bit in this chapter. Then finally, being comfortable with some of the more simple types of factoring. We're not going to get into crazy difficult ones. Now they are, I guess they're kind of crazy difficult because they have sine and cosine involved, or any trig functions. But remembering the different types of factoring. One of the things I'm going to tell you guys, and I tell my Algebra 1 students, Algebra 2, and even pre-calc, we remind you of this, is always look first for a GCF.
Degrees.
Now I'm going to warn you guys, one of these on this page are not factorable. So if you factored them all, you did something wrong.
Oh.
So one of them is not. Not everything is factorable. So looking for a GCF first is really helpful. Now in number 19, is there a common factor among those two terms? 4x. So we divide that out of each of the terms. So this is just going to be an x here. I divide it out here. And then I'm done because x minus 2 can't be factored. So that's a good example of GCF factored. All right. Now, another thing to watch out for is if there's not a GCF, then typically we go to this type of factoring where I want to like multiply to get x squared, and then I want to multiply to get the last term but add to get the middle term. So that's usually kind of your second step. So can we do that in number 20?
Yes.
We can. Because technically, x times x will give me x squared. This actually is a problem just like number 18 we had done. It's just like the reverse of it. I want to multiply to negative 9, but I want the middle term to cancel out.
3 plus 3.
3 and negative 3. Yep. Positive and negative 3 would cause that middle term to cancel out to give me that negative 9. How about 21? This is the not factorable one. So if I try to do this, first of all, there's no GCF. But if I try to multiply to get 1 but get the middle term to cancel, nothing will happen. So this one is not factorable.
Perfect squares has subtraction.
Yeah. So you guys, the rule with this is when there's two terms and they're both perfect squares, it still has to be subtraction. So that's why 20 works, but 21 does not. So since it's addition, it's called difference of squares. This isn't a difference of squares, it's a sum of squares. Now the last one's this is my favorite type of factoring, because you need a favorite type of factoring if you're a math teacher.
This is true.
Of course you do.
All right.
It's a prerequisite.
So, and I just make a big deal about this cat laughs at me, but so,
No, it's not even you. It's just the fact that you find this like that's my favorite.
all right. So we want to. So it's x times x gives me x squared. A little bit of a puzzle here. I want to multiply to get 12, but add to get negative 7.
Hey yo.
Dylan? Hey, yo.
Hey yo.
I want to multiply to positive 12, but add to negative 7. Yeah. Negative 3, negative 4 would be the numbers that would multiply to give me a positive 12, negative 7. And that's what we were looking for there. What? Oh, I thought you had it. Okay.
Yo, I see Dagan up there, no?
No, the purple one.
No, that ain't. That definitely is not.
Who's that supposed to be?
That's not. It does not have that big of a
Sam,
smile.
that it's 100%
Michael, who's the
smile.
purple one
The
supposed
fish
to be?
people
I don't know, I just drew it.
It's
Not good.
It's Jack Skellington with Killer.
Is that a really big neck?
it looks like Sam.
I don't know how it was a bit, but we don't have to see that. I know it's
Wow,
a
she mentioned it cool.